Look at some homework problems out of 4.3. We're going to look at 3, 10, and 48. So let's see what question 3 is asking us. Question 3, it's asking us to evaluate the 6 trigonometric functions of the angle theta. And it's giving us a picture with the point P is at -1, 2. Okay, so I'm going to draw my picture. Now if point P is -1, 2, that's going to put point P right here in quadrant 2. And now I'm going to make a nice right triangle with my hypotenuse extending from the point to the origin and dropping that perpendicular to the x-axis. I'm going to label my sides here. My x side, -1. Notice that the side length is 1. The negative just indicates direction. So that -1 means that I moved 1 x unit to the left. Since if I moved left, that's when my x, left from the origin, that's when the x values are negative. My y value is 2. Now I could do some Pythagorean theorem to get the hypotenuse there. So I could do 2 squared plus -1 squared equals c squared. And if I work that out, I will get c equals the square root of 5. So that is my hypotenuse. So theta is that angle. So just by looking at this, I know that my theta is, well, the point's in quadrant 2. So theta's got to be more than 90. So I've got to come up from the x-axis here and go past the y-axis. So I'm moving more than 90 degrees. So theta's, probably about 100 degrees. I'm just kind of estimating just by looking at the picture. But I know it's got to be more than 90. But the question isn't asking me to find the exact value of theta, just the 6 trigonometric functions of the angle theta. So I just have to evaluate now sine of theta, cosine of theta, tangent of theta, and the reciprocal trig functions cosecant of theta, secant of theta, and cotangent of theta. So now I'm just going to look at my triangle to determine all these ratios. So the sine of theta is opposite over hypotenuse, that's 2 over root 5. That makes the cosecant of theta root 5 over 2. The cosine of theta, adjacent over hypotenuse, that's -1 over root 5. That makes the secant root 5 over -1, or I could just say root 5. Tangent of theta is opposite over adjacent, 2 over -1, or I could just say -2. And the cotangent of theta is -1 over 2. So I've evaluated the 6 trigonometric functions of theta. So I'm done with problem 3. Let's move on to problem 10. Problem 10 just gave me the point. Point P is located at -3, 0. And it wants me to evaluate the 6 trigonometric functions for theta. Now I'm going to have to draw a picture here, though. It was not given a picture. So I'm going to draw a picture. And I'm going to plot point P. So point P is at -3, 0. So that is right on the x-axis there. Okay, now I notice that I'm not going to get a triangle in this picture. The point falls right on the x-axis. So I think the key information here that I should write down is I should write down the x value of the point. Well, that's -3. The y value of my point is 0. I should also write down the r value. R is usually what I will call the hypotenuse, but I could also think of r not just as a hypotenuse, but as the distance from the point to the origin. So if I'm looking at point P, the distance from point P to the origin is just going to be 3 units. It's 3 units away from the origin. So I can think of r as the hypotenuse, or I can think of it as the distance from the point to the origin. Excellent. So now I want to find the 6 trigonometric functions. So I need to find the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. Okay, so now I know that sine of theta is opposite over hypotenuse, but I could also think of sine of theta as y over r. Now, just a quick refresher about why that's the case. If I just look at a triangle in quadrant 1, just a general triangle with theta, x, y, and r, yes, I know that the sine is the opposite over hypotenuse, but if I draw all of my triangles such that they are perpendicular to the x-axis, such that theta is my central angle, and such that the hypotenuse is the distance from the point to the origin, the sine of theta is always going to be the y value over the r value. The y value is always going to be the opposite side here. So I could start thinking of sine of theta as y over r. That's just another way to represent opposite over hypotenuse. So now going back to my picture here of my point P at negative 3, 0, I don't have a triangle, but I do have a y value and I do have an r value. So I could say that the sine of theta here is going to be 0 over 3, which is 0. That means the cosecant of theta is going to be 3 over 0, but 3 over 0 is undefined. So I usually use a 0 with a slash through it. Represents the null set, or undefined, or no solution. Okay, cosine of theta. Now that's adjacent over hypotenuse, but I could also write that as x over r. So looking at point P here, my x value is negative 3. My r value is 3, so the cosine of theta is negative 1. The secant of theta will also be negative 1. Tangent of theta. Looks like that's going to be y over x. So it looks like it's going to be, for tangent of theta for point P, it's going to be 0 over negative 3, which is 0. Cotangent of theta will be negative 3 over 0, which is undefined. So I found the 6 trigonometric functions of theta. Now, I was not asked for this, but just by looking at the picture, looking at point P, I actually know what theta is in this case. Not estimating, I know exactly what it is. So if I look at the picture here, if I come from standard position on the positive x-axis, and I go around to point P, that's 180 degrees. So I know theta in this case is 180 degrees, or pi radians. So I wasn't asked to find theta in this case, but I just wanted to point out that it would be possible to determine theta here. I wouldn't need a calculator or anything like that. I could just look at the picture and know that theta would have to be 180 degrees in this case. So let's move on to 48. So 48 wanted me to evaluate without a calculator. So 48, they're saying find cosecant of theta. So they want me to find what the cosecant of theta is. That's my final goal. Oh, they also want me to find what the cotangent of theta is. So this means find cosecant of theta and cotan of theta. Okay. And now I have 2 given pieces of information. I know that the tangent of theta is negative 4 over 3. That's one given piece of information. And I know that the sine of theta is greater than 0. Well, if the tan of theta is negative 4/3, I know what the cotan of theta is. That's going to be 3 over negative 4, or negative 3/4. Excellent. But now in order to figure out the cosecant of theta, I'm going to have to draw a picture here. So I'm going to put my triangle in the plane here. Now I know that tangent is negative, because tangent of theta is negative 4/3. But I want the sine of theta to be positive, because it says that sine of theta is greater than 0. So I'm going to use a little mnemonic from class that I'll say all the time, ASTC. Just put those markers in the plane. It stands for All-Star Trig Class. It's a saying that's easy to remember, and it's just a mnemonic that lets me remember what functions are positive where. So the A stands for all. That means that all of the trigonometric functions are positive in quadrant 1. The S for all star, that stands for sine. That tells me that the sine of theta is positive in quadrant 2. The T, all-star trig, that stands for tan of theta being positive. And the C, class, that stands for cosine of theta being positive. So I can use that little mnemonic to remember what functions are positive in what quadrants, and then I can use that to quickly solve problems. So for example, I know that the tangent of theta is negative. Therefore, I could not put the triangle in quadrant 1. I could also not put the triangle in quadrant 3 because tangent of theta is positive in quadrant 3. Now, the sine of theta is greater than 0. That means the sine of theta is positive. Well, that means the triangle cannot go in quadrant 4 because in quadrant 4 cosine is positive. Sine is not. That means my triangle here must go in quadrant 3. My triangle must go there. Now, I'm going to label the sides. Tangent is opposite over adjacent, or y over x. So I know that it's going to be 4/3. But that 4 can't be negative. Really, the 3's got to be the negative there. Okay, and I know that this is going to be a Pythagorean theorem to figure out the r value, or the hypotenuse, but it's a triple, 3, 4, 5. So once I know that, I can figure out the cosecant of theta, which would be hypotenuse over opposite. So it would be 5/4. And if sine is greater than 0, sine of theta is greater than 0, then I know cosecant of theta must also be greater than 0. So I have solved problem 48.